All right, so yesterday we went over the basic sine graph. We said, all right, sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi, remember, if you were gone yesterday, we fixed this. Try to go quickly because this is the foundations of what everything is based on. Then we said sine of pi was 0. Sine of 3 pi over 2 was -1. Sine of 2 pi was 0. Just taking those straight off of the unit circle. All right. And then we made a little graph. We said that, okay, those 5 points make this little curve right here, but that we can extend that out because that takes us around the circle once, and we can then just keep going around and around and around the circle. And each time, even though our x value is getting bigger, our y value just keeps going up and down, right between -1 is the lowest point and +1 is the highest point. And so what that ends up looking like then is, go ahead and again, that was the tangent graph that we're not doing this year. Graph of sine of x looks like this, just over and over again, that little S curve. This is a sine wave. Notice that again, we start off here at 0. Here's the pi over 2, 1. Here's pi 0, 3 pi over 2, -1, 2 pi 0, and then it repeats. In other classes, in advanced math, maybe in physics, they will squish those closer together or stretch them out. We are not doing that. All of our graphs are going to repeat every 2 pi. That's called the period of the or frequency. Those are related. Again, terms that we're not going to use in this class, but you'd hear in like a physics class. For us, it's going to repeat every 2 pi. I think I showed you guys yesterday, though, what happens when you put a number out in front. So if I put a 2 in front, see how it gets taller? 3, 4, 5. It's stretching our graph out farther and farther away from the line we called the equilibrium. The equilibrium line, in this case, is just 0. And that number that I'm putting out in front determines how far away from that I go. And that's called the amplitude. Now, I think I told you guys specifically that for this class, and I think for physics, the amplitude is always the absolute value. We're going to call it just the positive version because you always go above and below the equilibrium by the amplitude. And so you always have a +1 and a -1. We're always going to pick the positive, the absolute value, the distance from the equilibrium to the highest point. Now, we also discussed what happens. Actually, let's do just one. What if I do y equals sine of x plus 3? What happened to that graph? Went up. The whole graph just up 3. Is everybody good there? Whole graph is 3 higher. Here's the one that's a little tricky. What happened to that graph? So it should have gotten shifted left or right. Can anybody tell which way it actually moved? It moved to the left. The only reason we can tell that is because we have the equation here. Because it would be identical if I shifted the graph forward to here. It would look exactly the same. So the only way you can tell which way you go is by seeing the actual equation or there being some other marker saying this is where we're starting. Does that make sense to everybody? So with this then, oh, actually, there's one other thing I want to show you guys. What do you guys think happens if I put a negative out in front? Flips it upside down. See it there? At this point, you have almost everything you need to graph any sine graph possible as long as it has a period of 2 pi. We're not going to get into the complicated stuff of what happens if you multiply the inside by something. But for us, that's all we need for every single sine graph that you're going to have. So let's try it. Skip the cosine graph for now. We'll come back to that in just a moment. It's real similar. Come down here. I want you guys to write in the general equation here. We're going to say y is equal to a sine. So a times the sine of x minus h plus k. A times sine of x minus h plus k. The k value we just saw, k value is going to shift our graph up and down. Jackson, hang in there. Okay, this is, again, just to be clear for everybody, this is unit 7 or section 7 and 8. We only have 8 sections. That's 2 out of 8. That means what I'm teaching you in the next 20 minutes is technically 25% of this chapter and could be about 20 to 25% of the test. But it should be easy. The trick is that it's brand new. This is something you haven't done before. You'll see pieces of it that are going to match, but I'm going to try to make it as easy as I can for you guys. So this K shifts up and down, but it's also our equilibrium line. It's that center line for the graph. So on this graph, everybody sees the +1 out there, right? It's not in parentheses, so we're assuming it's outside of sine. So that means our equilibrium line is at 1. Here's our equilibrium line. Try to make this a little bit more obvious. Is everybody okay there? We shifted the whole graph up 1, so the equilibrium isn't 0 anymore, it's now 1. We said that the A value is our amplitude if it's the absolute value. The absolute value of that is the amplitude. Oops. So we're just going to draw our maximum line, the highest one, as 3 above this. So 1, 2, 3 above. Our graph will not go above this line. And then same thing, it will not go below. Here's our equilibrium, 1, 2, 3 below. Our graph will not go below this line. Does that make sense to everybody? Our whole graph is going to be in between those two. Now, we would normally check to see if we shifted left or right at all. But since there's nothing inside here, the H value, this right here, the H value should be our shifting left or right. But in this case, there isn't one. So we're going to start at 0. And we're going to end at 2 pi. That's going to be 1 time around the circle. 1 time around the circle. Okay, we've done all the work now. All you have to do to make the graph is know the general shape. Remember that sine starts in the middle and then goes up and then back down and then back up. So when I graph this, I'm going to put a point at each of these hash marks. 1 here in the middle, 1 up here at the top, 1 here in the middle, 1 down here at the bottom, 1 here in the middle again. Do not make a Z, do not make straight lines here. Make it a curve as best you can. There's our graph of sine. Now, specifically, there's our graph of 3 times the sine of x plus 1. So again, the amplitude stretched out, and then we move the whole thing up 1. Does that make sense to everybody? Now let's answer a few quick questions. What's the highest value on this graph? 4. Where does that happen? Say it again. What's the x coordinate for that? So here's the highest point. Here's a mark. What is that mark? It's the maximum, but I need the x coordinate for that. Closer. Say it again. Almost. Really, really close. Yes. We're going to call it pi over 2, but Jack's right. You could say 0.5 pi. It's the same thing. This is halfway between 0 and pi. Halfway between 0 and pi is pi over 2. You can label that on your graph right away if you want to. That's always going to be pi over 2, halfway in between. It won't always be our maximum point. But the points that we're having on the graph are 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. So this one, pi over 2, that's not great. Let's try that again. That's where that happens. That's the x coordinate. What's the lowest value? Lowest y value on the graph. -2. And where does that happen? Yeah, so you can say 1.5 pi, 1.5 pi. You'll see it labeled most of the time as 3 pi over 2. That's how it would show up on your unit circle. That's how I'll refer to it. If you wrote 1.5 pi or 1.5 pi, that would be fine. So that's what we're going to put here. This happens at 3 pi over 2. Now they want us to extend the graph because it keeps going. It doesn't stop. This was one repetition, but we want it to keep going. We want it to keep going here. So again, continuing the pattern up to the top, back down. Over here, it's going to continue the pattern down and then back up. Notice how my points are always on one of those 3 lines. My points are always on one of those 3 lines. Also, it always follows the pattern. If I'm at the top, I have to go down. If I'm at the bottom, I have to go up. If I'm in the middle, I keep going the same way I was going before. Go ahead. Well, you have 2 people out. If you need to go, you can, or you can wait for one of the passes to come back. Actually, who is the other person? Oh, yes. Yeah. You just need one. One second, guys. Coming on tonight.
This class? Just kidding.
That's not what they joke about.
I'm so sorry.
Yeah, you're my doctor.
Wow.
All right, sorry about that little delay there. Let's go back now and talk about cosine. So cosine is going to be the exact same pattern, except we're going to start in a different place. All the rules, everything you do to graph it is going to look almost identical to sine. So cosine here, we're going to do the same kind of table, 0, pi over 2. Change the 3 pi over 2, make it pi. Change the 2 pi to 3 pi over 2. And change the 5 pi over 2 to 2 pi here. So we just have one time around the circle. And if you look at the unit circle or you look up the values for cosine, at the beginning, at 0, cosine is 1. But then at pi over 2, it goes to 0. At pi, it's at -1. At 3 pi over 2, it's at 0 again. And at 2 pi, it's back to 1. So its graph looks like this. Top, middle, bottom, middle, top. Do not draw a V shape. It's still a curve, even though those points look like an absolute value graph. if you actually graphed more than those points, you would see it actually takes a little while to start going down, and then it accelerates, goes down really fast in the middle, and then levels off. And it would make that curve. But again, we don't have time to graph 20 points every single time we graph cosine. So we're just going to say, I know this is the shape, and here are the important points that I need. That's one repetition for the graph, and then it would repeat just like the other one did. It would just keep going in both directions, following the same pattern. So if that's true, if it goes on forever in both directions, just like sine, our domain is the same. Negative infinity to infinity. Our range is the same. It still goes down to -1 and up to +1. And our amplitude is the same. It's still just 1. Does that make sense to everybody? So let's graph a slightly more interesting cosine then. Same rules as for sine. So if I come down here, so turn the page to the next one. This one doesn't have a k value. Doesn't have a k value, so that means our equilibrium is still at 0. Okay. There's our equilibrium. Our amplitude going up and down. Let's get that from right here, -2. So that means the amplitude is actually +2, right? The absolute value. So 2 above. 2 below. Okay. 2 above and 2 below. This one is shifted left and right, though. Now, which direction is it shifted, though? Is it shifted left or right? Always the opposite of what it looks like for those shifting left and right. So this is left pi/2. And they're always nice to us. They always make it line up with this graph here. So here's a point right there at -pi/2. That's going to be our starting line. Instead of ending at 2 pi, that also gets shifted left pi/2. And now again, we can kind of see a little box where our graph's going to be. Our graph is going to be right in here. Does that make sense to everybody? That the whole graph has to be right in there as far as the one repetition. Now, normally cosine, like we saw on the previous page, starts high and then goes middle, low, middle, high, maximum, equilibrium, minimum, equilibrium, maximum. Why am I not going to do that this time? What's the other change this graph has? The negative. The negative means instead of starting high, I'm going to start at the bottom. Start at the bottom, start low, and then go up. That's exactly right, Michael. So here we go. Start down here. Lowest point, then equilibrium, then maximum, then equilibrium, then minimum. Again, it looks like a V. Don't graph it like that. Make it that curve. And then you can, actually, they tell us to extend it later on. So we'll wait to extend it for now. It says, what's the highest value, y coordinate for this function? What's the highest point here? That makes sense? So it is 2. And then where does that happen? At pi/2 again, just happens to be the same as the last one. right? If you want at the very beginning when you're graphing these, you can just label this pi over 2 every time. Pi over 2 is halfway between 0 and pi. What's the lowest value? -2. But that actually happens twice, doesn't it? We have it down here at -pi over 2. And we have it over here at +3 pi over 2. That usually doesn't happen because they actually tell us with inequalities to graph usually from like 0. The graph is less than, or sorry, greater than or equal to 0, and then less than 2 pi. There's usually going to be one end that has the or equal to. And so that one gets the point. The not or equal to just gets an open circle. But they didn't give us that information here. So we've got two answers that are both equally correct. Then they have us extend it out using a different color. Again, if you don't have different colors, just make a dashed line or a dotted line. Just keep it going with your pencil, but make it obvious where the original one was. So here then, I'm going to extend it up and down, and on this side, back up there. Now, I didn't answer the last one on the previous page. Let's answer it now. The question on both 1 and 2, the very end says, explain how to find the amplitude from both the graph and the equation of the function. So the way to find the graph, or the way to find the equilibrium, or sorry, not equilibrium, the amplitude from the equation right? The absolute value of A from the equation. Or if you're finding it from the graph, it's the distance from the equilibrium to the crest or the max. Again, yesterday we mentioned that in like physics, you call it crest and trough. For us, you can do max and min, the highest and lowest point. Distance from the equilibrium up to the maximum point. Let me put this up higher for you guys to be able to see it. And that works for any of these, sine, cosine, any of them. That's how you find the amplitude. It's always positive. It's the absolute value of A from the equation, or the distance from equilibrium to the crest or the max. Does that make sense to everybody? Yes, Michael. The difference is that one of them is shifted by just a little bit. So like if I graph them both at the same time, they're off from each other. Now, if you go on to advanced math, you actually learn that you can substitute one for the other one with a little bit of adjusting. Does everybody see that if I take that cosine graph and shift it by pi over 2, it is exactly the same. And so you do a whole set in advanced math, and then in calculus, you'd use those as well, using what's called trig identities that you can substitute in one for the other with a little bit of a change. And you can do even beyond that. I've talked to you about how tangent is y divided by x. Y is sine, x is cosine. That means tangent is sine divided by cosine. And so they have a whole section that they do of these. They're kind of fun. They're like little puzzles of taking one function of trig and rewriting it in terms of other functions of trig. So that's kind of your answer there, Michael. They're identical, except for that shifted off from each other by just a little bit. So now let's go ahead and graph a few more, and then we'll be good with this lesson. What was that? Go ahead, sign up. Take the pass. So here, number 3, it's a sine function. So I'm going to find for all of them, this is all the same, right? Find that equilibrium. So the equilibrium is the K value back here. So I'm going to start with that one. This is my center line at +1. Thank you. Christopher. So here we got +1. Is everybody good with that? So everybody's good. The number on here, that's your equilibrium. Then find the amplitude. So in this case, amplitude is 3, right? The absolute value there. So 3 above, 3 below, right? Below the red line. So 1, 2, 3. That's where our whole graph is going to be, in between those lines. We're going to shift left pi/2. Left pi/2. So right there. Normally we'd, from 0. So is everybody clear that the normal span of our graphs is 0 to 2 pi? So when we shift left or right, that's what we're moving. So here we took the 0, moved it left pi/2. We're going to take 2 pi and go left pi/2 for the end. So right here, that would be our end. Again, if you take physics or advanced math, they'll change that. For us, though, it's always 0 to 2 pi. And then this is sine. So we should start in the middle. And then are we going up this time or down? Right. Normally we go up for sine, but because this one's negative, we're going to start in the middle, down to the minimum, back to the middle, up to the maximum, back to the middle, and make that sine curve. Does that make sense? Extend it out on both sides. Use a dashed line or a different color, or just somehow mark. Okay, I'm going to make a mistake right now on purpose. I want you guys to watch, see if you can figure out where I make this mistake, so that when you see yourselves do it, you notice, oh, that's wrong. I need to fix it. What's wrong here? Go ahead, Mahak. How do I know that I should not have gone down here? Right? It was down there already. It was going up this way. It should keep going up. I see that all the time. People forget which way they're going, or they copy it down wrong. Can everybody see now that the pattern is following the way it should? Just that S curve, that sine curve back and forth. Are we good there? Number 4, almost identical, right? So here, my equilibrium is at -1. So draw that line in. Here's -1. But now my amplitude is only 0.5, 1/2. So that means I'm going to go just a little bit in between here, 0 and -1. So half above and half a unit below. So our graph is going to be real squashed between those two lines. Right in between those. We're shifted left or right for this one? That -pi/2 is to the right. So we're going to start here. And the 2 pi end line also shifted right. And then the graph here, sine starts in the middle, goes to the max, back to the middle, down to the min, back to the middle. It's a real shallow graph. Does that idea make sense to everybody? Any questions about how we got that one? Yes. Go ahead. So then, if I extend that out a little bit farther, it would just go up here, stopping there, down, up, over. All right, and one last one. Leave that up for just a second, then we'll do one cosine, and then we should be good. Like, is everybody seeing how it's the same pattern every time? So for number 5, find the equilibrium. This one's equilibrium is at 2. Find the amplitude, which would be, the amplitude here is +2. Is everybody good with that? If I ask you for the amplitude on the test, you have to say the positive version, whether it's negative or positive to begin with. So the amplitude here is +2. That means 2 above the equilibrium and 2 below the equilibrium. This one's shifted left pi. Left pi gets us here. And then from 2 pi, left pi would get me to just pi there. That would be my ending line. And then the actual graph. For this one, for -2 cosine, am I starting at the top or the bottom? Right, cosine never starts in the middle. It's either top or bottom. If it's negative, it starts on the bottom, the mirror image kind of this original cosine graph. So starting down here at the bottom, middle, top, middle, bottom. Then connect the points with that smooth sine curve. Then we can continue it on. Now, for that one, does everybody see how it would look identical if we had shifted right pi instead of left pi? It would look exactly the same, which is why you want to mark which one was the original one, okay? So on the test, I think it tells you to box the original one to make it really obvious that this was the first one, and then this was the continuation. On the homework, it's not going to be that picky, but whatever the test tells you to do, whether it's highlight it, box it, make it obvious which one's the original one. Does anyone have any questions with what we did today for graphing sine and cosine? Those should be real easy on the test. The homework then is 8.7 and 8.8, just 7 through 10 for both of them. So four sine graphs, 4 cosine graphs. You've got almost 8 minutes here. You could probably knock out at least 2 or 3 of them. Some of you may have already done more than that. So let's go ahead and work on that. Ask if you have questions, help each other out. Let's get as much done now as we can.